Operations Research and Introduction. Operation research, it is made of two words, operations, which literally means actions that are applied to some problems or hypotheses. Research literally means an organized process of seeking out facts about some problem or hypothesis. Now, OR has been variously defined as by Churchman, Ackoff, and Arnoff. OR is the application of scientific methods, techniques, and tools to problems involving the operations of a system so as to provide those in control of the system with optimum solutions to the problem. H. M. Wagner defined OR as a scientific approach to problem solving for executive management. H. A. Taha, OR is a scientific knowledge through interdisciplinary team effort for the purpose of determining the best utilization of limited resources. OR, Origin and Development. In 1940, the term operational research was first coined by McCluskey and Tefton in a small town, Bautzen of UK. This new science came into existence due to research on military operations during the World War II. By 1948, OR had diversified from the military arena to the civil government and industries in the UK and the US. By 1950, OR had achieved recognition to be taught as a subject for study in the universities. OR Indian context. In 1949, Regional Research Laboratory located at Hyderabad was the first operations research unit established in India. At the same time, another unit was set up in Defense Science Laboratory to solve the storage, purchase, and planning problems. In 1953, Operations Research Unit was established in Indian Statistical Institute, Calcutta, with the objective of using operations research methods in national planning and survey. In 1957, Operations Research Society of India was formed, which formed a member of the International Federation of Operations Research Societies in 1959. The phases or the scientific method in operation research study. Judgment phase. It involves the specification of the real life problem, the determination of the objectives, determination of effectiveness of measures, formulation of an appropriate model of problem by utilizing the vital information so as to reach at the solution of the problem. The research phase. Observation and data collection for better understanding of the problem, formulation of relevant hypotheses and models, observation and experimentation to test the hypothesis using the available data, analysis of available information and verification of hypothesis, prediction of results. This is the most important part of the research phase. Then generalization of the results and consideration of alternative methods. Action phase. The recommendations for actions to those who first pose the problem. It could be the manager, it could be the owner, it could be the buyer. Putting the solution to work, that is, implementation of the solution. Scope of operations research. In the field of industrial engineering, there is a variety of problems, starting from the procurement of materials to the dispatch of the finished products. The management is always interested in optimizing the profits. In order to provide decisions on scientific basis, the OR study team considers various alternative methods and their effects on the existing system. The OR approach is equally useful for statisticians, economists, administrators, planners, agricultural experts, etc. OR study is complete only when we also consider human factors to the alternatives made available. Operation research is done by a team of scientists or experts from different related disciplines. For example, for solving a problem related to the inventory management, our team must include an engineer who knows about the stores and material management, a cost accountant, and a mathematician come statistician. For large and complicated problems, the team must include a mathematician, a statistician, one or two engineers, an economist, a computer programmer, psychologist, etc., depending upon the problem. Operation research applications. Finance, budgeting, and investment. It could be due to cash flow analysis, long range capital requirement, investment portfolios, dividend policies, etc. Claim and complaint procedure, credit policies, credit risks, and delinquent account procedures. Erroneous accounts which are in use. Marketing, product selection, competitive actions, timing, number of salesmen, frequencies of calling of account. Now, again, frequencies of calling of account, several salesmen are given several numbers to be contacted within a stipulated time period. So, frequencies of calling of account. Advertising strategies with respect to cost and time, effectiveness of market research. Physical distribution, the size and location of warehouses, distribution centers, retail outlets, etc. Distribution policy. Purchasing, buying policies or varying prices, determination of quantities and timing of purchases, bidding policies, replacement policies, exploitation of new material resources. Production management involves the physical distribution, the location and sizes of the warehouses or the factories, distribution centers and retail outlets, the distribution policies. Facilities planning, number and location of factories, loading and unloading facilities. Manufacturing, product scheduling and sequencing, stabilization of production, employment, layoffs, and optimum product mix. Maintenance policies, crew size, product scheduling and allocation of resources. Personnel management, mixes of age and skills, recruiting policies, job assignments, research and development, areas of concentration for the research and development, reliability and alternate decisions, determination of time cost trade off, and control of development projects. The characteristics of operations research includes number one, interdisciplinary team approach. This requires an interdisciplinary team including individuals with skills in mathematics, statistics, economics, engineering, material sciences, computer, etc. Holistic approach to the system. While evaluating any decision, the important interactions and their impact on the whole organization against the functions originally involved are reviewed. The methodological approach. OR utilizes the scientific method to solve the problem. It is not based on the whims and fancies of the owner. It uses some scientific method. The objective approach, or attempts to find the best or optimal solution to the problem under consideration, taking into account the goals of the organization. Methodology of operations research. Number one is the formulating of the problem, which is the foremost. Once you formulated the problem correctly, you are halfway through. The problem must be first clearly defined. It is common to start the OR study with tentative formulation of the problem, which is reformulated over and over again during the study. The study must also consider economical aspects. The environment. Environment involves physical, social, and economical factors which are likely to affect the problem under consideration. Our team or analysts must study the organization contents, including men, materials, machines, suppliers, consumers, competitors, the government, and the public. Decision makers. Operation analyst must study the decision maker and his relationship to the problem at hand. The objectives. Considering the problem as whole, objectives should be defined. Alternatives. The overall study determines as to which alternative course of action is most effective to achieve the desired objectives. Expected reactions of the competitors to the alternatives must also be considered. Deriving solution. Models are used to determine the solution either by simulation or by mathematical analysis. Mathematical analysis for deriving optimum solution includes analytical or numerical procedures and uses various branches of mathematics. Testing the model and solution. A properly formulated and correctly manipulated model is useful in predicting the effect of changes in control variables on the overall system effectiveness. The validity of the solution is checked by comparing the results with those obtained without using the model. Establishing controls over the solution. The solution derived from a model remains effective so long as the uncontrolled variables retain their values and their relationship. The solution goes out of control if the values of one or more variables vary or relationship between them undergoes a change. In such circumstances, the models need to be modified to take the changes into account. Implementing the solution. Solution so obtained should be translated into operating procedure to make it easily understandable and applied by the concerned persons. After applying the solution to the system, OR group must study the response of the system to the changes made to show whether the solution is effective or not. Operation research models. Classification of models by degree of abstraction. It could be mathematical models or language models. So book is an example of a language model. By function, descriptive models, predictive models, normative models for repetitive problems as a norm has been established. By structure, we can have physical models. Physical models, we can have a globe, analog or graphical models where some analogy is depicted, like we can show the flow of current by putting some bulbs in a model like we do in schools to show, or we can show that current is passing, or we can show that water is flowing through a dam by depicting it through some lights. Small bulbs can be used. Symbolic or mathematical models that we use, like for we can have a response like why is the yield obtained per acre of land due to various factors x1, x2, x3, so on, depending upon whether x1 could depict your amount of rainfall, the amount x2 could be the amount of fertilizers applied, x3 could be the quality of the seeds, so on and so forth. So symbolic or mathematical models are the most abstract in nature. By nature of environment, we could have deterministic models or we could have probabilistic models, the outcome of which is not certain, or we have some probability involved in those models. By the time horizon, we could have static models or dynamic models, static models which do not involve time. Characteristics of a good model. Now, assumptions should be simple and few. Variables should be as less as possible. It should be able to assimilate the system environmental changes without change in its framework. That is, the model should be flexible and it should be easy to construct. Now, constructing the model, the general form of a mathematical model could be O, where O is the objective function, O as a function of xi and yi, where xi denotes the controllable variables and yi denotes the uncontrollable variables, and f denotes the relationship between the objective function, the controllable variables, and the uncontrollable variables. Some of the common simplifications while constructing the models are omitting certain variables, aggregating or grouping variables, changing the nature of variables, like for example, considering variables as constant or continuous, changing relationship between variables, that is considering them as linear or straight line, modifying the constraints. The techniques of operations research, inventory control models. Operation research study involves balancing inventory costs against one or more of the following costs: the shortage cost, the ordering cost, the storage cost, the interest cost. Now, storage cost is the cost incurred while storing your inventory, and so on and so forth. Inventory control models help in taking decisions about how much to purchase, when to order, whether to manufacture or to purchase, that is, make and buy decisions. The most well known use is in the form of economic order quantity equation, EOQ for short, for finding the economic lot size. The waiting line models are used for minimizing the waiting time and idle time together with the costs. Waiting line models are of two types: queuing theory, which is applicable for determining the number of service facilities and or the timing of arrivals for servicing. Sequencing theory, which is applicable for determining the sequence of the servicing. The replacement models are used for determining the time of replacement or maintenance of item, which may either become obsolete, that means a better design is available, or become inefficient for use, that is, it is no longer in a condition to be working, and become infeasible economically to repair or to sustain. Allocation models are used to solve the problems arising when there are a number of activities which are to be performed and there are a number of alternative ways of doing them. The resources of facilities are limited, which do not allow each activity to be performed in the best possible way. Thus, these models help to combine activities and available resources so as to optimize and get a solution to obtain an overall effectiveness. Competitive strategies are adopted where the efficacy or the efficiency of decision of one agency is dependent upon the decision taken by the opponent agency. Examples of such strategies are game of cards or chess, fixing of prices in a competitive market, etc. Linear programming techniques are used for solving problems having many variables subject to certain restrictions. In such problems, objective could be to optimize the profit, optimize the cost, optimize the quantities manufactured, etc., whereas restrictions may be the policies of the government, capacity of the plant or plants, demand of the product, availability of raw materials, water or power supply, storage capacity, etc. Sequencing models are concerned with the selection of an appropriate sequence of performing a series of jobs to be done on a service facility or machine so as to optimize some efficiency measure of performance of a system. Like we can sequence two jobs on two machines. If there are two machines A and B in the order A, B, no passing. No passing means that the job has to go from machine A to B. We cannot sequence a job first on B and then on A. So we have to first sequence the job on A and then on B. Simulation models. Simulation is an experimental method used to study behavior over time. Network models. This is an approach to planning, scheduling, and controlling complex projects. Uses of OR. Problems dealing with the waiting line, the arrival of units or persons requiring service. Problems dealing with the allocation of material or activities among limited facilities. Equipment replacement problems. Problems dealing with production processing, that is, production control and material shipment. Applications of operation research. Some of the common applications are distribution or transportation problems. In such problems, various centers with their demands are given and various warehouses with their stock positions are also known. Then, by using linear programming techniques, we may find out the best economical distribution of the products to various centers from various warehouses. The product mix. These techniques can be applied to determine the best mix of the products for a plant with available resources so as to get maximum profit or minimum cost of production. Production planning. These techniques can also be applied to allocate various jobs to different machines so as to get maximum profit or to maximize production or to minimize the total production time, whatever the objective may be. Assignment of personnel. Assignment of different personnel with different aptitude to different jobs so as to complete the task in a minimum time. Financial applications. Many financial decision making problems can be solved by using linear programming techniques. Now, as for any procedure, there are also limitations of operations research or does not take into account the qualitative factors. Or techniques are applicable to only specific categories of decision making problems. Or methodology needs to be interpreted correctly. Due to conventional thinking, the recommendations made may be difficult to enforce due to a lot of resistance from the workers and sometimes even from the employer. Models are only idealized representation of reality and may not represent the true relationship between the dependent and independent variables.